Welcome back to the shop. So what I've decided to do is I just put a couple of jack stands on the ground and put them very forward on the motor mounts. And then I've just got something on the back that holds the back of the engine up. I've left the chains on because what I'm going to do is I'm going to put the pilot bearing in, which means I got to give it a couple of strikes with a hammer to get the pilot bearing set. And just in case something goes wrong, that's why the chains are still on it. But once that's done, I can remove the chains and then we can start bringing the bell housing over and we can start doing our measurements. Now, before you even think of installing the pilot bearing on the end of the crankshaft, make sure it is a good fit on the end of the input shaft, right? So you want to make sure that's a nice tight fit. That's exactly what you want. It spins nice and freely. Obviously, we'll oil that up or grease that up later, but basically, we know it fits here. And we know it fits over there, so let's put this home. Now before I install this, there's a couple of options. This is a solid brass bushing, but these will last forever as long as you don't sit there with your foot on the clutch all day, because the only time that the input shaft spins inside of this is when the clutch is depressed. Because when the clutch is engaged, the input shaft and the flywheel spin at exactly the same speed, so there's no wear and tear. So like I said, you have no problem with these. Now if you want to go with the roller bearing kind, go right ahead. It's up to you. But again, between the bushing and the roller bearing, and personally I've never had an issue with the bushing. But whatever way you want to drive this home, as I said, never just take a big maul and start banging on this, because you will crush the inside diameter here because you will flatten it out by hitting it with a hammer. So what we want to do is simply put this in place and tap it in place. Okay, so I've just placed it in place. Now I put a little bit of blue Loctite on it. You really do not need that. The idea is this will sit in there and it will press in hard. But I always like to seal things up, and then when I have to remove this, or if I ever have to remove this, all you got to do is use your sliding hammer with a little hook on it and it'll pull right back out. But what I'm going to show you here is, like I said, I like to go around the perimeter of it, and again, never strike it right on the dead center. All right, so let's drive this home. Perfect. As you saw, I was going around the outside of it, never striking it dead center. Again, dead center will collapse the circle on you. You have to make sure you just go around and around and around, and it slowly works its way in. So what's the first measurement we can take to make sure that the stab depth of the input shaft is going to be right for this engine? So what I like to do is take a flat edge across the back of the crank. Right, so this is across the back of the crank, and I'm going to put a ruler to the flat surface of the block, right? That flat surface, obviously, is the same flat surface that is on the bell housing. So when those two surfaces come together, plus the thickness of the spacer plate, we have to make sure that that input shaft is going to be actually in the engine the right depth, right? We can't have it too long or it's going to bind, and we can't have it too short or, of course, it's not going to work. So what I like to do is I take a flat edge right across the end of the input, the crank, and then I measure to the block, and what I have is I have about 5/8 of an inch, right? So over half an inch. So 5/8 of an inch from the end to the flat spot. Now, therefore, if I take the measurement from the input shaft to the outer flange of the bell housing, that distance should also be 5/8 of an inch minus the thickness of the spacer plate. Let's go check that out. Okay, so if we take a flat edge and put it up against, you'll notice that the input shaft sticks out a little bit further than the transmission, which is fine. Remember, this is going to have to go into that pilot bearing. Now we know we have 5/8 of an inch sticking out from the plane of the back of the engine. But again, that's fine as well, because 1/8 of that is going to be eaten up by the spacer plate, which means about a half an inch. So I've set my micrometer to about a half. I got 5.03. I mean, that's close enough. But basically, if I now take this flat bar and put it across and then go in that half of an inch, that comes right here on the input shaft, and that is perfect, right? Because remember, this is going to insert now into the end of the crank. The pilot bearing is going to work its way down to about this far on the input shaft, and I won't have any issues whatsoever with this binding with the pilot bearing. Now, here's the difference. This transmission is a T5 World Class built before 1994. And why is that important? Because if you're going to go with an aftermarket bell housing that was designed for a T5, you need the shorter input shaft. And that is because this bolts directly to the flywheel and therefore is further forward, and therefore you need that shorter shaft, which was before 1994. In 1994, Ford moved the engine and transmission a little bit more forward in the car, and therefore they had to bring the transmission a little further back. So they just made a longer bell housing in 94, and therefore what they did in 94 is they increased the length of the input shaft to compensate for that. So you cannot use a transmission from 94 or newer if you're going to go with this aftermarket bell housing. But if you have an original bell housing and you are going to convert to a T5 and you're going to use that spacer plate I talked about earlier, that spacer plate was designed to compensate for the additional length on the input shaft. So you therefore, if you're going to go with an original bell housing and a spacer plate or an adapter plate, then you have to buy a transmission that was made after 1994 because you need the additional length on the input shaft, because your adapter plate is going to push your transmission further back, and if you have the little short shaft like I do from 94 or older, it won't even reach your engine, right? So that's not going to work either. Okay, so as I said, before we get started, we have to put the spacer on. As I said, the spacer is about 1/8 of an inch thick, so that made up for that 1/8 of an inch for the insertion of the input shaft into the pilot bearing. Now, I had to buy a new spacer. The reason is that the old spacer is for an automatic transmission, and as you can see, it's missing the bottom. Now, the reason behind that is an automatic transmission, when you bolt the transmission onto the engine, you then have to bolt the torque converter onto the flywheel, and you need access to do that. So this little flange at the bottom snaps off so that you can have access to it. But with a manual transmission, you don't have that. Manual transmission, you bolt everything onto the flywheel, you make sure everything is good, and then when you mount the transmission, you're done. There's nothing else to adjust other than the thrower bearing, and we'll get into that. But basically, this will work fine, and as far as I'm concerned, it goes right on the dowels, and it goes right on, so it's perfect. Now, this next step is really important, all right? So this is the flywheel for this 289. It's 28 ounce balanced flywheel. It has 157 teeth, so the diameter is smaller. You gotta watch. There's two types of flywheels. You're gonna find 157 tooth and 164 tooth. 164 tooth's a little wider, but it will not work in this application. It won't actually even fit into the bell housing. So I had to make sure it's 157 teeth. I had to make sure it's obviously the right bolt circle. I have to make sure that it's the right counterbalance, right? Because we're running a 28 ounce offset on the crank. So this is exactly what we need to bolt onto the back of this. Now, you also have to be very careful because it is keyed. The bolts are not exactly perfectly centered, but neither are the bolts on the back of the crankshaft, and that's by design so that when you put these two together, there's only one way that it will go on. And the reason is because that offset has to be in exactly the right spot. It's like a tire, right? If you don't put the balance on the correct spot, then you make it even worse. So this has to be oriented only one way and one way only. So let's get this on. Okay, so I put the flywheel on, and then I started to spin it, and I would put a bolt in, make sure the bolt went in, and then I would try to put the other 5 in. And if the other 5 didn't go in, you then took that first bolt out, rotated at one spot, and try it again, try it again, try it again. And you keep doing that until all 6 bolts go in without a problem. There's no binding on any of these. These all turn in nice and easy. So now that I'm ready to go, I'm now going to pull the bolts out, and I'm going to go get my red anaerobic thread lock sealer. The reason it's important to do both, you obviously want a thread locker. You don't want these coming loose. But you also want a sealer because these bolts enter the oil galley right behind the crankshaft. Those bolts that go into the back of the crankshaft actually enter into the oil area. And you don't want oil coming around the threads and getting out, because if it does, it's going to come right out here and get all over your clutch, and that's not going to be a good thing. So you have to seal these suckers. So I'm going to go get the red anaerobic. I'm going to seal these. We'll put them in, and then we'll torque them down, and then the flywheel is ready to go. Of course, it's filthy, but I'll clean that with brake cleaner once we're ready to put the clutch in. But I'm going to get my hands all over this as I'm putting the flywheel on, and I'm going to be putting, all sorts of gauges on here. So again, at this point in time, let's just bolt this in. Okay, moment of truth. So the bell housing is bolted on, the flywheel is bolted on. I have a dial indicator that is magnetically attached to the flywheel, and then of course I have the dial running on the inside circumference of the transmission opening. And what we're going to do is rotate the engine. Now, a 5/1000th of an inch out is acceptable, no problems, everybody's happy. If I start increasing from 5 and maybe going to 6 or 7, although that is still tolerable, it is not optimum. Now, anything after 7 or 8 it will cause damage. You will burn your pilot bearing out, or if you have even a roller bearing, you'll burn it out as well, because the input shaft will no longer be centered and it will be forced off center, and it will burn when you got the clutch in. So what I'm going to do is I'm going to rotate the engine 90 degrees, and we're going to do a measurement. As you can see, I marked the bell housing at 0. We'll go 90, mark it, 90, mark it, 90, mark it, and we'll take a look at the numbers. And based on those numbers, we'll determine whether or not this is out of round, and if it is not true, what are we going to be able to do to move this bell housing? So let's give it a turn. Okay, so let's turn this 45 degrees. I can watch it on the front, so we can move the whole thing. And there's about 45 degrees. And we take a look at the numbers. And we are 1, 2, 3.5, but this is actually negative. So that is going towards the 90 side of 0. So this mark here is actually 3, and as I said, 3.5, but it is minus, all right? So now let's move it to another 90, and that'll bring us to 180 degrees. Okay, so now we're 180 degrees off of the original marking of 0. And in this case here, we are now plus. So if we mark this one, we are now plus, that's 3 right on the nose. That's 3 plus. And then we go another 90. And we are 5 plus. Okay, so what does that mean? This is 5 plus, which means the dial indicator is being depressed to get into the plus, which means this is over this way. This is this way. Over here being minus, that means when the dial indicator is on this side, the dial indicator is actually going out past 0, which means this is further away from the dial. So what we need to do is we need to take this bell housing and we need to shift it that way by about 3 to 4/1000th of an inch. Now there's really only one way to do that, because these dowels are tight fit here and of course on the other side. What I'm going to do is I'm going to have to take a file, and I'm going to run the file on the outside here, on the outside, so that the bell housing can move that way. And I'll have to do that on the other dowel as well, on the aluminum. I'll have to use a round file on the inside over there, and that'll allow the bell housing to shift that way. Now I'm hoping that there's enough slack in the bolts that when the bolts are loose, and then I simply apply pressure to the bell housing after I've taken some material off, that will then bring this truer. Now, at the top I'm 0, at the bottom I'm +3. In all honesty, up and down, I'm good with +3.
because that's 3/1000th of an inch between the top and the bottom, and that's well within the 5/1000th of an inch, which is acceptable. But here I've got 8.5 thousandth. We have to balance that, and the only way to do that is to move the bell housing that way, about 3 to 4 thousandth, and we'll be good to go. So I'm going to pull the bell housing back off. I'm going to get my round file into these dowels, make them a little bit bigger but more oblong so that the bell housing can go that way, and then we'll remeasure it. Okay, like I said, so a round file in and just a couple of strokes straight down and then just a little bit around. I'm trying to obviously make it a little bit oval. Now if I take the meter or my gauge, and of course we're at zeros, and I put it in here widthwise, oh, that moved. These things are so sensitive. Well, 498.5, I mean, it just wiggles when I remove it. But now if we go this way, .505. So we've actually moved this now 5/1000th of an inch, and that was with just like 3 strokes. So as I said, be very careful. But the good news is, even though I went 5/1000th over, it doesn't mean I have to push the bell housing all the way over. Second thing, all of the bolts that go in don't have a lot of space in here, so I'm not going to be able to move the bell housing that much anyways. But at least I can now. The dowels are not going to stop this bell housing from moving to the right. And again, we'll put it in, we'll readjust it, we'll run it around and see where we're at, and then hopefully we're within that 5/1000th. Okay, so bell housing's back on, moved over a bit, up a bit. We're back at 0. We're zeroed on the gauge. Let's bring this now 45 degrees. This was a 3.5 minus. And we are now a 2. So we moved it in 1.5. Again, small steps. Remember, never try to do too much or you will cause a problem for yourself later. Now, straight up and down, we are at 0.4. That used to be +3. So I guess when we moved it, it kind of adjusted it a bit there as well. And now we go over to the other side, 45 degrees over the other way now. From the -2, we are now 4. So that gives me a 6. Now, is that good enough? I mean, 0.5 is acceptable. I can't believe 0.6 is devastating, right? I mean, so I'm thinking 6/1000th of an inch instead of 5/1000th of an inch. And you know what? A lot of this will have change when I reassemble it anyways, because I still have to take all this apart and put the clutch back on anyway. So it really doesn't matter from the tolerances like that. But I now know that as long as I put this together, put the pressure on the side before I tighten the bolts, I'm 6/1000th of an inch. And you know what? I'm going to live with that. So I hope you found this useful. This is the end of part 1, because in all honesty now, I mean, I've got to put the clutch on and I got to do all the transmission work and the throwout bearing. I think that's going to be a separate section on its own. So keep tuned, and like I said, thanks for joining, and please hit that like button, and I'll see you next time.